Hey everyone, so today we're going to be translating lines. Not a whole lot of new concepts about translating, but definitely some new definitions that we're going to hopefully be more aware of as we go through this lesson. So the learning target is we will be able to translate lines along vectors. Remember, vectors always have two directions. They have a vertical or a horizontal direction, comma, vertical direction. And don't forget the date. And don't forget to put the title of the notes in the table of contents along with the page number. So as we take a look at our first question, we have, what is a straight line? Maybe try to pause the video, maybe try to come up with your own definition. But hopefully we come up with something along the lines of a straight line is something, or we know that it goes on forever in both directions. But we know that like a line looks like a straight line with a couple arrows, but in reality a line is really just a series of points so close together that it looks solid. So it's actually an unlimited amount of points. So if we kept zooming in, it would more look something like this. Okay, but the dots are so close together that it looks solid. So our next question is, our next instructions are draw a straight line through point P that is parallel to line L. So please pause the video again and draw a line through P that is parallel to line L. So this could be line L. And please draw a line parallel to that through point P. So I have to go here. So we should get something that looks something like this. And we can call this line, since it's a different line, and it might even be translated line L prime. Okay, sorry, I switched them to capital letters. So what are some characteristics of parallel lines? What do we know about parallel lines, and what do we know they're never going to do? So let's define parallel lines. So one thing we know about parallel lines is they never intersect. That's the biggest thing. They never intersect. But how do we know they never intersect? And they never intersect because the distance between them is always the same. Distance between them is always the same. So if the distance between them changed, the two lines would probably intersect at some point, either on the left-hand side or the right-hand side, depending on how much the distance changes frequently. So now what I want you to do is try to draw a second line through point P that is also parallel to line L. So again, please draw a second line through point P that is also parallel to line L. So please pause and try to do so. So now I'm hoping that you're kind of confused. So you might have drawn a line that maybe looks something like this. try to draw a line that's really close to parallel. Call this, since this is the second one, we can call this line L double prime. And if we try to get this closer and closer to parallel, it's not really going to be parallel unless we get it to be the exact same line as line L prime. So, which brings us to our first rule. This rule is there is only one distinct. Distinct means unique, or one and only one. There's only one option. Distinct, unique. There's only one distinct line through P, point P, that is parallel to line L. Again, we can get really close to becoming parallel, but it's just not going to happen. Only one line is possible through P that makes it parallel to, or L prime parallel to L. And we use two long vertical lines to mean parallel. So we can say L is parallel to L prime. Okay, two long parallel lines. That's the symbol for parallel. Parallel. Okay. So now let's get on to moving or translating some lines along a vector. So if we take a look here at this example, it says, please translate line L along vector AB. And then it says, what do you notice about L and its image L prime? So let's take a look. Here's our image, or sorry, here's our vector AB. Remember, vector is just a specific length and direction. So it doesn't matter where this vector is in space. This vector is always AB, and it's always going from pretty much just horizontally, from left to right. So it doesn't matter where I put this vector. All we're doing is sliding it from the distance A, or from point A to point B in just that specific distance. So what I want you to do right now is take your transparency and put it over line L and trace it and label it L prime. Okay, so now we're just going to slide this line along vector AB. So again, vector AB just moves horizontally. So I'm going to go from A, and slide it over to B. Okay, all I did was slide it from here to here. What do you notice about line L and line L prime? So hopefully we see that line L and L prime are really just the same line. You can't really tell that they're in a different line because both lines go on forever, and L prime is laying on top of it. So if you looked at it from an aerial view, and if my line was a little better, if we didn't take into account human error, they would lay exactly on top of each other going on forever in both directions, so you could not tell that there were two lines. So by sliding a line along another line, it's really just the same line. Which brings us to another definition. So hopefully we're putting all our definitions in our glossary. This definition is called coincide. Coincides. Which means there's two lines that overlap that create just one line. So we could say that line L coincides with L prime. So again, coincides. They're inside each other. They belong together. They overlap. Okay. One lays on top of each other. It's really just the same line. Please try to do example 2 on your own, where it says line L is parallel to vector AB. Translate line L along the vector AB. Okay. So even though the vector, so please pause this and try it on your own. So even though the vector is not on the line, all the vector does is just tell us where or which directions to slide and how far. So again, our vector is just moving horizontally from left to right, and we're moving the length of A to B. So we're not taking our line and moving it upwards, because the vector is not moving upwards. We're just moving it the length and direction of the vector. So from A to B. A to B. We call this L prime. So again, what do we notice? We should notice that again, L coincides with L prime. So really, it's still just the same one. Example 3, we have, again, please translate line L along vector AB. And what do we notice about L and its image, L prime? So again, please take our transparency, trace over L. You can label it L prime. And now our vector AB is moving from down to up. So now we translate our line L prime from south to north. So again, what do we notice? Are the lines parallel? Or do they coincide? You let me know which one. And last but not least, please do example 4 on your own. This is just a quick review from yesterday. Thank you.